Hello everyone, welcome back. Let's talk about another easy problem on Leetcode today. Clear digits, Leetcode 3174. In this problem, we are given a string S and our task is to remove all digits by doing this operation repeatedly. Delete the first digit and the closest non-digit character to its left and return the resulting string after removing all digits. Now in terms of constraints, string contains only lowercase English letters and the input is generated in such a way that it is always possible to delete all the digits. That is, if we have a number 3 here, we will always have some non-digit number to its left that can be deleted along with this digit 3. Then in example 1, for the given string ABC, there are no digits, so we will not delete any character and our output string will be ABC as well. But in example 2, for the given string, we have two digits 3 and 4 in it. So when we see 3, we delete 3 and the closest non-digit character to its left, that is B. So now we get the string as C4, but the string still has a digit 4 in it. So we will delete 4 and the closest non-digit character to its left, that is C. So we will get the empty string in the end. Now in terms of solution, a naive approach can be to run the simulation as described in the problem. So we try to modify the string in place. This can be easily done in programming languages where the strings are mutable like C or C++. But in Java or Python, we have to use mutable implementations of string like string builder and list respectively. So we will iterate through each character in the string using an index I, and whenever we find a digit, we remove it along with a non-digit character on its left, and we repeat this process until we reach the end of the string. Now in this example, when our iterator reaches I equal to 2, we find a digit 3, so we remove it and shift all the character on its right to the left. So now our string becomes CB4, and then we also remove the non-digit character on the left and move this 4 to the left. So now our string becomes C4. Again we see a digit 4, so we remove it and then our string becomes C, and then we also delete the non-digit character on the left. So now our string becomes empty, and now we are done with all the characters, so we will return empty string as our answer. And the time complexity of this approach is O of n square in the worst case, because for each digit we perform two delete operations, which involves shifting all the characters on its right to the left, making the time complexity of delete operation O of n, and in the worst case there will be n by 2 digits in the string, leading to time complexity of O of n square. And in terms of space complexity, it will be O of 1 in programming languages like C++, but in programming languages where we have to create a mutable string implementation like Java or Python, it will be O of n. And given this problem is an easy one, it may be accepted as well. I have covered this solution in the post linked in the description below in case you are interested. And now the question is, can we do better? And the answer is yes. The bottleneck of the naive approach is that deleting a character takes O of n time. So to avoid this, instead of modifying the string, we can construct the answer from the scratch using some data structure. And you would have guessed it by now, we can use a stack. Why? Because a stack is a last in first out data structure. And here, as soon as we see that a character is a digit, that is, the last character we saw is a digit, we can efficiently remove the last added non-digit character, which will be like a first out operation. So we are seeing the last digit and remove the first non-digit character. So for example, we can add the characters to the stack. So first character we see is C, we add it to the stack. Next character we see is B, we add it to the stack. Then we see a digit which is 3, so we pop out B from the stack. Then we see 4, which is again a digit, so we pop out C from the stack. And in the end, all the remaining characters in the stack will form our answer string. And also, we don't need to actually use a stack as an additional data structure, because we can simulate the stack behavior with the mutable answer string like string builder in Java or list in Python, and we can use it to build a string. Let's also quickly look at it. So when we see the character C, we add it to the mutable string. Then we see B, so we add it to the string as well. Next we see 3, which is a digit. So we will delete the last added character, that is B, from the string. And note that because we are building this string from the scratch, we won't have any character on the right that we have to shift. making the delete operation O of 1 now as compared to O of n in the naive approach. Then next character we see is 4, so we delete this C as well. And in the end, once we are done with all the characters, we will return result or answer string as our answer. And here it is an empty string. Now in terms of time complexity, it will be O of n because we are going through each character in the string only once. And stack push and pop operations or string delete operations in this case will take O of 1 time. And in terms of space complexity, it will be O of n because we have to use this stack like data structure, which we will also use to store the resulting characters. And now we can quickly jump into the code part. First, let's create the mutable string answer, which will act like a stack. And in Java, we can use a string builder implementation for the mutable string. Now we will iterate through each character in the input string and check if the character is a digit. And for that, we can use isDigit method on the character class, or we can write our own function if the interviewer insists that. And then we check that our answer string is not empty. Note that we don't have to perform this check because in the constraints, it was mentioned that input is generated in such a way that it is possible to delete all the digits. But I am just adding this code to show that even if it was not possible, this is how we will handle it. And if both the conditions are true, then we will remove the last character from the string. And one way to do this is we can use delete caret and pass in the index of the last character, but that internally calls system.arrayCopy, which involves shifting of characters. So instead, in this case, we can just call setLength method and reduce the length of the string by 1 because this is more efficient, as internally we are just setting the internal length of the string without shifting the characters. And if the character is not a digit, then we will append it to the result. And once we are done with all the characters, we will return our answer. Now let's submit this code. Awesome. And again the question is, can we do better? And the answer is no, because we have achieved the most optimal time and space complexity with stack-like string approach. However, suppose the string was mutable like in C and C++. In that case, we can actually do better regarding the space complexity by modifying the string in place and using a two-pointer technique similar to how we handled remove duplicates from sorted array problem. In that case, one pointer or iterator, let's call it I, iterates through the string, and the other pointer, let's call it j, keeps track of the position where the next valid character should be placed. And in the end, we can return the final mutable string back using only the valid length determined by j, which will be j minus 1. Let's see this in action with the string ACB34. Initially, both the iterators I and j are positioned at index 0. First character we see is A, which is a non-digit character, so it is valid for now. Hence, we will move the j pointer forward, and in any case, we will move the I pointer forward to explore the rest of the string. Then the next character we see is C, which is also a non-digit character. So we will move the j pointer forward, and in any case, we will move the I pointer forward as well. Then the next character is again a non-digit character, so we move both I and j forward. Then the next character we see is 3, which is a digit character. But in the output string, we shouldn't have digit and corresponding non-digit character on the left. So this makes this character invalid. Hence, we will not move the j pointer forward. And to remove the corresponding non-digit character on the left, we will move the j pointer backwards. Note that j pointer points to character B, but B is not a valid character and our valid string is AC. So at any point, j pointer will be the place where we will be inserting the next valid character, and the substring 0 to j minus 1 will be our valid substring. Now let's move the I pointer forward to explore the rest of the string. Then the next character we see is 4, which is again a digit character. So we will move j backward again. And now j points to index 1. And now we are done with all the characters in the string. So we will truncate the substring to size j minus 1 and return the substring a as our answer. And now suppose we also had character d at the end of the string. So our string was ACB34D. Then in that case, we would have moved the I pointer forward. And because it's a non-digit character, we will insert it at the j point because that is the point where we insert the valid characters. So our string would have become ADB34D, which is still okay because we care about only the substring from 0 to j minus 1, which is still valid. And after performing this change, we move the j pointer forward so that we can insert the next valid character at this index. But we are done with all the characters, and so our valid string will be AD in this case. Now the time complexity is still O of n because each character is processed only once and both I and j pointers traverse the string in a single pass. But the space complexity in this case can be O of 1 if the interviewer is fine with mutating the string and provides us with the mutable string. So now let's jump into the code part. Now in Java, we don't have mutable string, but either we can use a string builder like we were doing earlier, or we can convert this string builder to character array, because in any case, string builder uses a character array internally, and also it will be easier for us to perform the two pointer operations. Now let's define our second pointer. Let's call it j to keep track of the position of the next valid character in the answer, and we can keep the I pointer as is and run the loop. And if the character is digit and j is more than 0, then move the j pointer to the left, but it can't go below 0. So to fix this, we can just use the maximum of either j minus 1 or 0. And if it is a non-digit character, we will just store this character at the position j and move the j pointer forward. And again, note that we don't have to perform check for j greater than 0 in the if condition, because in the input we will always be able to delete the character. But if it was not possible, this is how we will handle it. And in the end, we will truncate the string and create a substring of size 0 to j minus 1. J here is non-inclusive. And now let's submit this code. Awesome. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.